Hello everyone, my name is Ratthicha Parinthip and today I will present you about the OCR system for Thai documents. So we use tesseract, YOLOs and vector-based search. Let's start with the introduction. So OCR stands for Optical Character Recognition. It means changing the scanning Thai documents into the text that computer can read. It helps us with searching, editing, and getting structured data. The challenging of this project is Thai language is very complicated letters, and they have many fronts, and also some documents they have a lot of tables. So I have to say, in this presentation, I will talk about the system overviews and how does it works, and we have the demo at the end to explain some code and show the demo to you guys. So let's start with the system overview first. So we get the Thai document in PDF, so we have to change the PDF page to image. Then we use YOLO to find the text areas, and then we crop that text area. If it text, we send it to Tesseract to read the text. If the page has the tables, we extract them too, and then we combine the text and turn into the embedding for smart searching, and then user can use all of this through the seamless interface. So let's getting more details on the system overview. So first, it's a step of PDF to image. So we convert each PDF image into the image that use a tool called PDF to image. This is important because OCR tool like Tesseract can only read from image. This method helps to support many pages and they have high quality result. So the next steps, as I mentioned, it's a YOLO. So we use the YOLO's 11 and with trainings. So here's how it looks like. So we use YOLO V11 and customs trainings to find where's the text on each page or on to the image. These trainings, so we train it on Thai documents so it works better than the default version, especially for the page that have a lot of tables and a lot of text. So the pictures on your right hand side is the output for bordering box where the text is. As you can see, we can label the page header, the title, the text, the list items, and also the tables. So next one, moving on to the tesselects. So for the tesseract steps, we use the tesseract to read the image. The normal tesseract is not very good with the Thai font, so we train it using the very famous font for documents called Thai-Sarabun font. It helps the system read it more better, even for the complicated letters or the Thai numbers. Because actually, the Thai numbers, if you use just a tesseract, we cannot read the Thai number, especially the number 1 for the Thai numbers. So it's look like dotted letter. So basically the normal ones will read it as a dotted for number ones in Thai. So moving on for the table extraction. So if the Euro found that this page have a tables, they will crop that tables and we send it to the table extraction to read it. So we use the tool called image to tables. It can find the rows and the columns and they can get the text from each cells. It's very useful for form schedules and invoice. It's also lets us export the table data, so you can see the examples on your right hand side. So if it's just the normal tesseract, we don't use the image to tables, it will read not in the cells. so examples it release like 111มีการนำเสนอเอกสารทางด้านเทคนิคแผนงาน15 so the number 15 will appends in the sentence so we want it to read from each cell so we decide to use the image to tables. Next one, let's talk about the accuracies. So I do these tables to let you guys see the comparison between the tesseract without trainings, fonts, and with the training one. So without the trainings, the accuracy was about 90.26%, and with the training, it's increased to 90.45%. It's a small change, but it's still better. So the next one, I will show you guys the comparison between the YOLO V11N and with the training one. So the default one get 81.17, but after training it reached to 91.40. So the training YOLOs on Thai document is really helps. So let's moving on. After we combine the text that we got from both tesseracts and image to tables, we embedding it. So we turn it to the vectors using a Thai language model called ConGen. This model understands the meaning of sentence, so users can search so they don't need to type the exactly word or the keyword, or they have to spell it very correctly. The system can the system can find a result that having the same meaning. So next is a demo of our systems. I will show how it works in code step by steps. Okay, so here is our demo. So let's start at training YOLO first. So actually I do the data for training YOLO in the Label Studios. So I do it manually. So label each document. Is it table? Is it caption? The titles? All list items? And then when I already got all the data, I export it and train the YOLOs by preparing the dataset first. So we split the training and test. So here is how the code look like. So we split the train test, and here's all how to prepare the data sets, and then we can start training it. So we use the Ultralytics for training YOLO, so you can load the default models first. So we use the YOLO version 11N, and we can load the models and set the parameters and starting trend. So it might take long time, but the result will look like this one. So after we already run all this one, we can see the output here. So here is my output. So here is our models, and it shows config metric, F1 curve, also have P curve, and all information is in this file. After that, okay, let's moving on to the tesseract. So for the tesseract, I searched it and I got the model from his GitHub repos. So this GitHub name National Document OCR. So he already trained the fonts, and the font he trained, he used a TH-Sarabun, the one that we want to use. So he already provides us a Google Drive, and he give us a model. So here I already loaded, and you can see he have like Thai-Sarabun trend data. So we use his Tesseract training. And if you're interested in training Tesseract with fonts or any language, you can basically search on YouTube, and I recommend this video from this channel. So he very explain in details, and he do the step by step, so you can clone his repos and training Tesseract by yourself. And I will add his video clips link in the descriptions of my presentations. Feel free to click and watching his video clip. And then let's moving on to the how Tesseract and YOLO's working together. So okay, so as I mentioned earlier, we convert PDF to image first, and we use YOLO. So let me go to the YOLO part. So here's, as you can see, we use our YOLO. So this experiment name train 12, so it's this one, the training one. Okay, so we extract YOLOs, and we also check if it's the box that YOLO detect, is it overlapping, so we remove it and we process the contents. And here is on the OCR process. So after the YOLO already labels the documents, so if it's the text, it will crop that text box and send it to the Tesseract to read. And we also have the cleaning paddle for Tesseract too. So we have like remove space between numbers, remove space between Thai letters. We have like handling the one that very problems in this project, like it's a pause, or it's actually have the small space here, as you can see, so we have to split it. And for the OCR table, so we send it to the image to table to extract the table. So when we already extract the tables, we just combine the cells together. And here is the process for OCR. So we check the crop image, and if it picture, headers or footnote, just continue Tesseract readings, and if it tables, just use the image to tables. Yes, and we already combine it here, and then we use the we moving on to the embeddings. So we embedding it by using the model's core ConGen, as you can see here, the ConGen one. So you can so you can call the models and let it embedding your sentence that you get from Tesseract and image to tables. And yes, that's it. And the next part, I will show the demos on the stream list. So here is our stream list. So we call the function from that file, as I mentioned you earlier. So let's run streamlit. So terminals, new terminals. So we use stream to run streamlit. We have to type streamlit. Okay. So here is how our streamlit look like. So I will it will ask user to drop the files So I already download the example. I already download the example file. So I use the TCAS, this one from Kasesat. So I open it. So as I mentioned, it will convert PDF to image, and it will take a moment for processing OCR. Okay, when it's already read by OCR, when it already finished, user can click and enter the keyword for searching. For examples, when we just click on the enters, so it will show the text, the contents in the documents which related to our keywords. So the first one is the one with have the most similarity scores. So it will show it's in the page 2, and the text is Karasamax. So we can open the files. Here, and it's in page 2 here, การรับสมัคร. So we can read and we can search where is this keyword is belong to. So it's help us to like searching easier. If you have like 100 page of document, you just search from the keyword, and it will shows where is it, or where's this keyword related to which contents in the document. So that's it for my presentation. Thank you for watching.